Della, how do I break down 15 into a product of primes? 3 times 5. Carly, how about 30? For the sake of what I'm doing, I'm going to put it in this order. But yes, you are right. Can't call on someone who's not here. Lenora, 60. I'm concerned about the amount of whispering on this warm-up. Ellie, 120.
3 times 2 times 5 times 2 times 2.
Yes. Again, I'm going to write it in this order. There's a reason behind that. Okay, so I got 3 times 5, 3 times 5 times 2. Do y'all notice the pattern here?
Yes.
Okay. Now, there's a more traditional way to write this. This is called prime factorization, by the way, when you break something down into all prime numbers getting multiplied together. 3 times 5 times 2 to the power of 3. This is 3 times 5 times 2 squared. This one right here is 3 times 5 times 2 to the first. And this one's 3 times 5 times 2 to what power? I heard it. 0. So, would you agree with me that the pattern for this sequence is that it keeps multiplying by 2?
Yeah.
Why? Because the numbers are being doubled, because that's like the actual pattern. Because it's what type of a sequence? Geometric. What is a sub 1? 15. What is R? 2. The constant ratio. It's the number it multiplies by every time. It's kind of like the constant difference, but it's the geometric version. So, if that is the case, the reason that this keeps increasing by 2 is because it keeps getting multiplied by an additional r. So, would you agree with me that this is 3 times 5 times r to the 0th power? It's essentially what this is then. And this is r to the first. And this would be r to the second. And this would be r to the third. Why did I write a 3? Don't mind me. You saw nothing. It was never there. So that number that keeps increasing exponents is actually our constant ratio, where you're multiplying by an additional r to get from term to term. What about the 3 times 5? Where do you think that comes from? It's a sub 1. Stop. So this is a sub 1 times r to the 0th. This is 8 sub 1 times r to the first. This is a sub 1 times r squared. This is a sub 1 times r to the third. Now this is the first, second, third, and fourth term in this sequence. What do you call the first term of a sequence? A sub 1. What do you call the second one? A sub 2. No, I absolutely cannot move it to where you can see. I am incapable. Move the laptop away, please. Thank you. What do you think the 80th term would look like? A sub 1, I heard that, times R to what power?
81.
I heard three different things. I heard 79, 80, and 81. 79. In other words, the 80th term would be 15 times 2 to the 79th power. Don't put that into your calculator. You're not going to get a number out of it. It's too big for the calculator to actually determine. What do you think if I just talked about a generic nth term? What would a sub n be? A sub 1 times r to the power of, not n. How did these relate every time? Minus 1 and minus 1. Guess what? That's the equation for a geometric sequence. That's what we're getting into today. We're focusing in on geometric sequence equations. .3, day 1. Focusing in on our geometric sequences and series. Much like with arithmetic, I'm giving you the geometric sequence explicit formula. An explicit formula is one that I can give you the equation and then I can ask you to find whatever term in the sequence I want you to find. We'll eventually talk about recursive formulas in this class as well. Goes a sub n equals a sub 1 times r to the power of n minus 1. Where a reminder, a sub n is either the nth term or a sub n is equal to the equation. A sub 1 is still the first term. R is that constant or common ratio. If a sequence has a D value given to you, it is arithmetic. If it has an R value given to you, it is geometric. N is still the position specifically of the nth term. It's where something is located in the term. You're going to see questions in this section very similar to what you saw for 10.2. The difference is going to be the setup of what's given to you. We're going to find the indicated term. Sometimes I might give you a list of numbers in the sequence like this. 3, 6, 12, 24. Now, since we are now starting to mix in geometric sequences, now we have to be diligent in making sure that we are verifying if we're working with arithmetic or geometric in the first place. Is this an arithmetic or a geometric sequence? How do you know it's geometric? Geometric multiplies by the same number from term to term. We should also be in the habit of checking if it is a sequence or if it is a series. which is the case here. It is a sequence. Why? There's two things that we're looking for to make it a sequence. First off, a sequence is a list of numbers with pattern. Is this a list of numbers? Yes. And the second thing we gotta check is, are you asking for the sum of the list or just information about the list? Did I ask you to find a sum? Did I put plus signs? No, those are series things. Series ask you to add it up. They say find the sum or they put plus signs. This is a list and says nothing about finding the sum or the total or adding anything up. So that's what keeps it being a sequence. Now, since it is a geometric sequence, the only thing that I have available to me is this. This formula can be used to write an equation for a geometric sequence, or it can be used to find indicated terms. When I'm finding an indicated term, first thing I should probably figure out is which term am I looking for? The terms are the numbers in the list. Which number in the list does it want me to find? How far in does it want us to go? 15. It's telling us n is 15. Which means we are looking for a sub 15. It's what we want. We were given that n is 15. So I have n. I have the a sub n that I want. Or at least I know that that's my question mark, I should say. What's a sub 1? 3. What's r? 2. A sub 15 is equal to a sub 1 times r to the power of 15 minus 1. I plug in what I know to find what I don't. What I don't know is a sub n. A sub n is what I'm looking for, a sub 15. Now, when you type it into your calculator, I would be careful. That exponent can cause some issues. But what is 15 minus 1? 14. Then when you plug it into your calculator, I would write 3 times 2 to the power of 14. I got 49,152. And that's what you should have gotten. Now be careful when you do this. One very common error that I see people do is this. They put 6 to the power of 14 in their calculator. Is 3 times 2 to the power of 14 equivalent to 6 to the power of 14? No, order of operations, the exponent would have to go first. These are not equivalent. And if I put 6 to the power of 14 into my calculator, all of a sudden it gives me this. What's it mean when I see that, by the way?
There are 10 more numbers behind.
Times 10 to the power of 10. That's what that E tells us. So this particular one would have been 7.8364161 times 10 to the 10th power. It's always times 10 when it's the E, and the number it gives you is the exponent. When it is a positive 10, that's essentially telling you they have to move this exponent 10 times to make it larger. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 7, 8, 3, 6, 4, 1, 6, 4, 1, 0, 0. That's how big that number is. Should I expect to get some really big numbers with geometric sequences? Yes. Can I expect to get some really small numbers with geometric sequences? Leslie, yes. The numbers can get really small too. In situations where they're small, let's just, for the sake of argument, say I had 7.8. I'm not putting all those decimals. Times 10 to the power of negative 5. Again, on a calculator, they would have said 7.8 e negative 5. That means move the decimal place 5 times in a direction that makes it smaller when it's negative. 1, 2, 3, 4, 5 decimals now here. It's 0.000078. So that's scientific notation. In theory, we should know scientific notation. In practice, how many of you remember scientific notation? Okay. Still finding the indicated term. A sub 8 for negative 729, 81, negative 9, 1. Is this arithmetic or geometric? Or neither? Geometric, how do you know? It's dividing by negative 9. Now, when we deal with geometric, dividing by negative 9 can help us identify that it's geometric, but what I actually want is what it multiplies by. To divide by negative 9 is to multiply by what? Negative 1/9. To divide by something is to multiply by its reciprocal. So it is geometric. Is it a sequence or is it a series? It is a sequence. It is a list of numbers that I am not asking you to add up. Okay, so again, this is my formula. A sub n equals a sub 1 times r to the power of n minus 1. Do I know a sub n? No, that's what I'm looking for. Specifically, a sub 8 equals. Do I know what a sub 1 is? Negative 729 times. What's r? Negative 1/9 to the power of 8 minus 1. N is 8 because of this. Remember that subscript is the n value. Now when I go to plug it into my calculator, I'm going to put negative 1/9 to the power of 7. Now, do you notice that I put the negative 1/9 in parentheses here? Is that necessary? Yes. It's necessary for multiple reasons. If r is a fraction or if r is negative, it can make a difference. Well, that's fun. How many times am I moving the decimal place? 4. In the direction that makes it bigger or smaller? Smaller because it's negative. 1, 2, 3, 4, Decimal would go right there. What goes in the open spots?
0.
So 0.00015. That's enough. It's a tiny number. Okay, one more finely indicated term problem, and then we're going to switch up the instructions. What if I ask for the first 5 terms? Many of y'all overthought this on the quiz. If I'm looking for the first 5 terms, what do I call them? A sub 1, A sub 2, A sub 3, A sub 4, A sub 5. Sound right? If I'm looking for A sub 1, what variable does that tell me about? N. It tells me N is equal to 1. If I'm looking for the first 5 terms, I'm plugging in 1, 2, 3, 4, and 5 in for N. That's all it wants me to do. If it gives me the formula, I'm plugging numbers in. So I'm doing 2 times 1/2 to the power of 0. Which just happens to be 2. I'm doing 2 times 1/2 to the power of 2 minus 1 is 1. And 2 times 1/2 to the power of 1 also happens to be 1. I'm doing 2 times 1/2 to the power of 3 minus 1, which is 2 times 1/2 to the power of 2. 0.5. And I continue plugging in, or there is a shortcut at this point. Does anyone know what the shortcut is? Shortcut is recognize your pattern. How's it going from 2 to 1, and then to 0.5, and then to 0.25? It's dividing by 2 every time. Could I just start dividing by 2 and get the number rather than put in the entire big formula? Yeah. 0.125. So, sometimes you'll see that. Sometimes you'll see this question. Write an equation for the nth term. When I ask for the equation of the nth term, I'm asking about a specific term, and therefore it must be a sequence. Series will always ask you to add things up. Is this arithmetic, geometric, or neither? How do we go from term to term? If it's hard to tell on the first one, look at the second. Change. appears to be multiplying by -8. And it does that for everyone. Which makes it geometric because it's multiplying by the exact same number every time. Now, geometric sequence formula is this. Now, if I ask you to write an equation for something, whether it be a linear equation, a quadratic equation, a sequence equation, some things stay letters. The domain and the range pieces, the input and the output pieces stay letters. The things that are changing. When I look at an equation, when I look at a sequence, is a sub 1 something that changes from problem to problem? Let me rephrase. Within this sequence, as I go from one term to the next, does a sub 1 ever change? No, it's still the first term. Does r ever change? No. Does n change? N is the position. As I go from one term to the next, is the position changing? Yes. Is the a sub n, the number in the position, changing? Yes. Because I started at -1/4, and then I went to the next one, and now it's 2, and I went to the next one, and now it's 16. Which means a sub n stays a letter, n stays a letter, a sub 1 and r become numbers. Those are the things that when I look at the same sequence, a sub 1 is always the same number, r is always the same number. When I look at this list, the first term doesn't change. What I multiply by doesn't change. So a sub n equals, what is a sub 1? -1/4. Times, what is r? -8 to the power of n minus 1. If you write it like this, it is wrong. I mentioned earlier, there's a very important need for parentheses when r is either a fraction or negative, or both. Make sure that goes in parentheses. When in doubt, always put it in parentheses. You can always just be like, I'm going to put parentheses here, and ta-da, now my formula is that. Can I simplify this? No. Arithmetic sequences, their formulas could simplify because you could distribute and combine like terms. Geometric, you put the numbers in, and you say, ta-da! And if I don't hear a ta-da on the next quiz, I'm marking you all off. Obviously not really. But I would get a good chuckle out of it. To write a sequence, you plug in a sub 1, you plug in r, or if it's arithmetic, you plug in a sub 1, you plug in d, and then simplify. That's good, because this unit's not as long. Oh, I need to end the